All right, let's check again. Let's check again. The thing is, I want to see it on my machine. Like I want to see the issue on my machine. Okay, so I reduced the resolution and I reduced the bitrate. So I follow what they are saying. So let's see. Yeah, also my machines are Android. Oh, so you can see now. Okay, so it was maybe either the bitrate or the resolution. Ah, that sucks. Okay. All right. Okay. Okay. Right. So let's do this. Okay. Nice. Thank you for helping me solve this issue. It's really weird because also I see it on my machine. So like, how does this work exactly? Yeah. Right. Okay. So what I was talking about is that there are projects that are similar to this idea that I'm trying to do. Pinthos is one of them. And if you search for Go role engine, you will notice that there are some projects that implemented this rule engine. They call it like business rule engine sometimes. And the idea is that the business define certain rules and the system combine the rules together and try to optimize them and apply them. And you can tweak the rules at runtime and you can enable and disable them and have A/B testing on them and have some on staging and testing and development and live. And you can like mix and match and they can like interact with each other. So the system can get complicated over time. So this is kind of a way to organize the logic. So it would be easy to add more logic and it would be like the logic would be how to say it parallel to each other, so they don't really intersect with each other. So if you are trying to remove a piece of logic, you kind of remove the rule or set of rules which define this specific feature or this specific experiment. It's really interesting if you think of it. It's since we did that, it's been actually our velocity has been very high even before the AI. And okay, let me explain how this works. Let's also close some tabs. Okay, so the idea is that your system should have, how to say it? The system should have sources of events. So you are reacting to messages from Kafka, RabbitMQ, HTTP, gRPC, SQSQ. You are pulling some system, and when something changes, you emit an event, or even you are monitoring your machine locally, and when an error happens, you emit that as an event. So some rules or like some part of the system should react to that. Like maybe in Linux, like what was it called? There's something called reflex, where it watches the file system events, and when a file is edited or saved or deleted or created, it emit events, and then you can react to these events. This is how hot reloading is happening. So they listen to the fs notify, is it called, or fs events, and listen to that and then react to this. So yeah, from a backend perspective, what we are trying to do is react to some of these. Yeah, works fine now. Thanks, Islam. Yeah. 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 So that is what we will try to build. We will try to challenge ourselves a little bit with this system. Okay, so let's talk about the basic idea. So you have a source of events. So this is the basic thing. You have a source and you have the event, and then you have some kind of a condition. Oh God, I suck at this. Yeah. And if the condition is true, you you are going to do some kind of an action or transformation, action or transformation. So it takes the event and then you do something with it. You want to do some kind of a side effect. Like you want to write to a database, or you want to like count something, or you want to like modify that event, like mutate it, or you want, like you want to react to it somehow. And this action should be getting the input, formalizing what are the side effects you want to apply to the system, and it will output that as another instance, another struct, another object. So the idea is that this is a transformer. It gets an input, what event happened, and then it outputs another maybe event or some action or something that needs to be applied to the system. It doesn't apply to the system directly. So it should be kind of uh, like pure functional, if I would say. So it shouldn't have any side effects. It should just get the input, inspect the system, and see what to do with this input. Like if it's an HTTP request, yeah, we will get that, and then we'll check the system. Okay, we need to query the database. We need to check the cache and do all of this calculations, and then we need to write that to HTTP response. It doesn't write by itself. It has to output that as a certain data structure that then can get applied. So what will apply this side effect or apply this output should be another another component. Let's call it a destination. Sometimes they call it sink. Yeah. So you have a source of events, you have a condition. If the condition is true, so the condition determine, okay, like this rule needs to react to this event, or this doesn't need to react. Sometimes it's like if you have an HTTP server, it's like when you define routes and you say, okay, like if the path equal to that or in this pattern and it's get, you need to do this kind of render this kind of form. If it's post, you need to like write to the database and render that form. If it's like delete, you delete from database and you render the success, and so on. So the condition gets the event, which is the HTTP request, and then decides if this rule should process it or not. So that means our system can have multiple rules that can be executed for the same event. So you get one event, should fan out to the rules and check, okay, like this condition is true, this is false, this is true, this is false. And the true ones can execute their actions. And then when the action executes successfully and return the output, should give it to a destination to write it. Write it to a database, write it to HTTP response, write it to whatever you want. Sometimes, for example, you want to, this is the simplest thing, like a sinker from Kafka. You consume a Kafka topic and you write to a database. So your message is coming from a Kafka topic. This is the event here. And then you check, oh, okay, this is actually a valid message and I need to store it. And the action will maybe minify it, maybe convert it to something simpler in your system. And then it will output what the structure that needs to be written to the database. So the destination will be database and the table name, for example, and it takes the structure and write it to the database, upsert or something. So this is the idea. All right, so you have a source, you have an event, you have a condition, and here if this is a yes, you do the action. If it's a no, you just skip this rule, ignore it. Yeah. So when you have like the same source and you're trying to react, like for example, in Kafka, you can listen to the same topic, and if you listen to the same topic with the same consumer group ID, it's going to, if you create two consumers even in the same process, it's going to load balance the messages between both of these. It's going to distribute the messages. So if you have like four partitions in the topic, for example, it's going to send the two messages, like two partitions to the first consumer, two partitions to the second consumer. So what you need in this case, you need to have, for the same event, we need to process multiple rules. We need to, so that means you can't have 2 or 3 or 4 consumers. What you need is that you need one consumer and it emit one event and then it fans out. It takes this event and the system should be taking this event and passing it through all the rules. So the system should look like that. I will remove this just for brevity. Okay. So the system should be reacting to multiple of these. So you have different conditions, you have different actions, different destinations, and you're getting an event, and you need to react to it. React to it. Here. It's exactly the same event. So if the user is responsible for defining these rules, the system is responsible for doing this wiring. It's responsible, so let me write this. So system responsibilities needs to do wiring between sources and rules, like a fan out, for example. It needs to manage the rules, as in activate the rules. You want to add a rule in runtime, deactivate it, as in remove from the system. What else? Handle errors, for example, or panics. One rule failing shouldn't impact the rest of the system. One rule panicking shouldn't be panicking the whole process. So the system in this case is like a safety net. So handling panics. Harmony. Okay, what I'm working on, I am working on a system that should be handling events and react to it. So it's like sometimes they call it a rule engine or business rule engine or an event machine. So the idea is that you can get events from anywhere and react to it in different ways. So you can get events from Twitch, for example, like a chat, and they print it to standard output. And another rule that takes the same message and write it to SQLite. And the same thing, and maybe build analytics over it, like write to analytics system per user, for example, to know like the engagement per user, if you are trying to apply that. It is a bit abstract, but you can think of it this way. It can also be used for HTTP service, because you, in any HTTP service or gRPC or whatever, you are reacting to events. The event is a customer request, an HTTP request, and the rules is like handling this request or not. And this is like the mux in Go does that, where you are registering path patterns and what function should be executed. What we are trying to do is having this mux, but not only for HTTP, but for anything that can emit events. In the HTTP, in this case, the HTTP server is the one that is source of event. But in the case we're trying to build here is that the source can be anything. So we're trying to unify the interfaces with sources of events and destinations, as in what systems can be affected by that, right to a database, right to HTTP, right to like a Prometheus or something, or a S3 or whatever. So you're trying to unify the interface. So your system can be described as parallel logic, where you are getting an event and you can react to that event in multiple ways. And these ways are not really not interleaving with each other. So they are not tightly coupled. So the system would be easy to modify. And in practice, this worked for me in a production system, and this really high performance system. So that's what we are trying to do. Yeah, so I think I gave some use cases that should be useful for this. So yeah, this could be replacing anything that is reacting to events. Anyway, all right, so you have a source and you have some conditions which says, yeah, this rule would like to process this event or not. So it's like a gate. If the input passed this gate, then you can do some kind of an action. Like if it's an HTTP request and this action should be querying the database, querying the cache, and returning like the information that should be rendered. And then the destination should be HTTP response. And that destination should write the output of the action into the HTTP response. So you wouldn't have only one function that handle the input, the guarding, the transformation, and writing. They would be different responsibilities. And it will get clear over time. It will get clear over time. Redux for front-end state management. Maybe. I'm not familiar with Redux, to be honest, so I can't talk about it. I'm trying to steer away as much as I can from front-end. It's dumpster fire, if I would say. Come on, man. Like I wake up every day and it's like, yeah, we have like 30 front-end frameworks. There are these libraries, and there are really small libraries. You don't need all of that. Anyway, that's rambling for another time, maybe. All right. So your system should be handling a source of event. Like, let me maybe have an example here. So you can have a source, which is Kafka message. This is like really simple thing. Like, let's have here example, and one here you have like listening to a Kafka, and then you validate. So this is like a gate. So you validate the event. So you say, okay, like actually what we consumed now is invalid because you didn't put all the fields that is required. So I'm not gonna process this message. Or yeah, this is valid. Let's put it in our database. So it's valid. And we don't, this is the simple thing. It's like pass it or yield, where you don't do anything to the object, you just take it and pass it down, and you can in the end have a database table. So this is your source, condition, action, destination. The same thing can be also done this way. So you can have this look like that. So it's invalid. So if it's invalid, you can write that to maybe like error or log error, or send, no, maybe we can send that to Slack. And these are running in parallel. So yeah, so you can do that. In other cases, if you're trying to implement that, you would have had this logic in one block where you have an if else. If it's valid, do this. If it's not valid, do this. But the problem with putting it in one block is that it's coupled together. So if you're trying to remove this logic, this Slack logic, you are modifying also the part that is handling this writing to the database table, and you can mess with it. So if you already split it, you can remove this part without affecting this part at all, because they are in two different places, and the engine is merging them together. And this will appear in the will show up in the while we're implementing that. So yeah, so you can have this Kafka, like let's say you are consuming the Twitch messages, and yeah, you can check is that like a valid message as it doesn't have profanity, for example. Let's save it to the database that has profanity, or we can send to Slack so we can block. Yeah, you can also do that. You can you can say if it's invalid, then you can do this. Invalid, then convert it to user name, and here block in Twitch chat. So you can remove the part that is sending to Slack and still block, or remove the blocking and just get warning in Slack. So you are splitting your logic to be parallel to each other. So it wouldn't have like if else's and switching and stuff, which makes it brittle. And when you change it, for sure something will be fucked up in some other place of the code. Like I had really bad experience with that in one of the systems, and this is why I had to think about this. Because usually at work, project managers think about their systems in terms of business rules. Yeah, when you get that, you need to react to it that way. When you get that, you react to it that way. So when you build the system to reflect the mental model they are using, that makes it easier for you. Sometimes they call it ubiquitous language, where you and the project manager or product owner, whatever you call it in your organization, you're both talking about the same thing or using the same terms, using the same mental model to express the system. So that's the idea. So you can listen to Twitch messages. Uh, you can have another source where you are listening to Twitch follow events, and you can process it in a different way. Like follow, you can. Oh, damn! But there is a nice. There is one thing also that I'm doing wrong here is that I try to like speed up. I don't need to speed up. We have time, and I will try to stream every day. So I need to be comfortable at slowing down. So just bear with me. So that's a Twitch follow. We don't need maybe any filters, so no filter. So we don't need to check for anything. And then you need to just pass it. You don't need to do anything. And then you can just write to a database table the list of followers. And maybe you can upsert. So if somebody unfollowed and then followed, you know, the created time was that, and then the last time they followed was in the updated at. And you can write this destination to be generic, and then we will explore this concept in details. It's very interesting, and it has a lot of implications that makes it easier to develop. Your problem after you build a system like that is that because it's easy to add rules to it, it's really easy to lose the narrative about what's happening. Because it's easy, like you get project requirement and you check, oh, okay, now I need to add these rules because of this experiment or because of other stuff that are happening, and you start to add rules that handle the events. But then you forget that there are already existing part of the system that is handling some other stuff. Maybe you need to remove it, maybe we don't need it at all now. And so it is sometimes, because it's easy to extend, it's easy also to lose narrative. And people are really suck at keeping context, even suck more LLMs at keeping the context of a whole system. And if you are working with a system for multiple years, it accumulates a lot of that. So your problem wouldn't be modifying the system as much as trying to keep track of what is in the system and how it works. And yeah. So this is what I'm trying to build. And if you built a system like that, then you get a really interesting property where you can have attributes or kind of a middlewares, or how to call it. Okay, so the basic thing here is that you are having a gate and then an action and then a destination. The gate could be optional, so you don't have to validate anything or filter anything. The action could be optional, so you don't have to do any transformation, use the input as it is, and the destination. And sometimes also maybe you need the destination to be optional. So with that, you can have this kind of architecture. Like this thing, this like source, it's like this part here, this part here. Let's call it, let me extract it and call it something. So let's encapsulate it, right? Let's encapsulate it. Let's encapsulate it here. And here you go. So source, condition, action. So let's call this a rule. Nope. Let's call this here. This is a rule. And when you do that, now you can build over it. You can add features that trap these rules. So when you are implementing any of these rules, you can turn on this feature and it would be just applicable to any rule. Let me explain. So let's say you need logging. So what you need to do is just have a way to wrap all of that, wrap this whole logic. So you need some wrapper here, not the wrapper that sings, the wrapper that, yeah, the joke. So you have something here that logs. So, and you can wrap all of your rules that way. So when you define a rule, the system can wrap it, wrap the logic with logs. So when it gets executed, you know what is, like if there is an error happened here, an error happened here, you try to write to the destination and it failed. So you can wrap this logic and get the input and the output, and you can log the errors. So you don't have to log the errors in here, you just need to return the error. And then the middleware can log this error. So you try to write to something, or you try to write to SQS and it failed, whatever, throttling or whatever. Instead of logging the error in your logic, no, like you just define the rule and the system already will wrap it with logs. You can wrap it with something else, you can wrap it with metrics. So it can say this rule actually executed successfully, this like 3 times, errored 4 times, skipped 5 times, and so on. So you can have metrics. You can have cache. You can have cache. So you can do this. You can wrap that with cache. And the rule can say, and this cache will take the rule definition, and if the rule says, yeah, cache it for a week, cache it for 1 hour in memory, this cache middleware can introduce this logic. If the rule doesn't have cache in it, then this middleware can just, fuck off, doesn't really do anything. So this is the general idea. You can have a cache, you can have a way to tell it, okay, you need to cache only when this condition is correct. Or you can invalidate the cache when that is happening, when something changes in this input. So you can make really smart things that trap the basic logic of source, condition, action, and destination. Wrap that with middlewares depend on the definition of the rule. The middleware can decide if it add the logic or not. And you get that for free for every logic you add to your system. So now you can have logs that says how many times you wrote to the database table, how many times you wrote like an invalid message to Slack, how many times you blocked someone, because the logs shows you what happens in for this event, what kind of every rule, what did it do, so you can see it in the logs, and the metrics will report for every rule what was happening, as in was it skipped, was it executed, was it errored. So you can then have a dashboard and look at all of that. So it's quite interesting because of that, because it makes it really easy to wrap your basic logic with more features. So you get features for free. You don't have to, in your code, to wrap with metrics, because sometimes they tell you, okay, you need to instrument your code. You don't get instrumentation for free in Go, for example. You have to go and they make a span of the open telemetry, for example, make a span from the context, and you have to, you know, to report it like in the span in the end of the function. And so you have to instrument your code. But if the instrumentation is happening here in a central place that wraps any basic logic, then your logic here can say, yeah, I want metrics, or it can even be by default on. And it will get it for free. You don't have to have it here in the action. You don't have to have it in the destination. You don't have to have it here. So your engine or your business rules engine can have that for each one of these rules. So you can have caching for free. You can have in the rule say, okay, like cache it for 1 week, and this cache will check the definition, and yeah, we'll cache it for 1 week. Okay, so I will check first if there's something in the cache, and I will return immediately if this input has some response in the cache. If not, I'm going to continue to execute all of that. Yeah, the condition, the action, and destination is going to go over all of this. So yeah, you can also have a once. You can say here, execute once. Execute this rule once per input. So if the same input came again, you don't execute it. So this once you can, in the definition of the rule, you can say execute it once every 4 weeks. So this once middleware will check, oh, the rule want to execute once every week, every 2 weeks. Then let's check first if we executed it, if we execute this rule for this input over the past 1 week. If yes, then we skip this rule. If not, then we will execute the rule, we'll continue. And in the end, we will write that, yeah, this input was executed, like this rule was executed for this input right now, and like the TTL after 1 week. So you can get also once feature, and you can turn it on for anything. You can block a person once per month. So even if they made another offense, they don't get blocked. Or in Slack, if somebody like wrote profanity and it's like 100 message, you execute it once per user, so you don't have to spam your Slack messages. So yeah, that is the idea. So when you execute this core, you can then make it as like an onion with all the logic around it. Also, you get some interesting properties, which is you can write your rules in your programming language. You can have a DSL that you may define a structure or something. And then you can also have a transformer or something that reads the rules from files like JSON files or YAML files, and add these rules to the system, or read it from a database. So when the system goes up, it goes connects to the database, checks rules in some table, deserialize it, and enable it in the engine. And when something changes in the table, try to activate and deactivate and change these rules. So if you came up with this logic and it worked already in your programming language, and you have a DSL for it, then you can have something that could transform any other format to this like rule definition. Yeah, it's a bit abstract, but it will you will understand it over time. This is why I'm doing this because I think this is actually not a new idea. I said Benthos already do that, and there are other rule engines, open source, that do that. But developing this engine is really fun to do, and I had a lot of fun developing it, and I think it would be fun to develop and stream it. So yeah. All right. So what do we do now? Now we talked about the concept. I think now we can try to write some kind of a, how to call it, a spec, or yeah, let's write some kind of a specification for it, how the system should behave. Like write all of these ideas in a way. Sometimes they call it technical design document, like TDD, or sometimes they call it like a spec. Sometimes they, with the AI, they call it spec driven development. What bullshit. It's like vibe coding, but with extra steps. Anyway, so let's try to do this. So maybe I can show you also how this looks like in terms of uh, let's see, in terms of code. So okay, we need to pick a system, a name for this system. Let's be creative. What do we call it? What do we call it? So it's a system that handle a lot of events and react to it. Oh, I missed something else too. There is something that is interesting if you have your logic uh, defined as like a structure or data where you can activate and deactivate it. Oh, also I missed this part where you can say you can have another a wrapper that says, okay, this rule doesn't get executed in this environment. And in the rule, you can say, yeah, I need to execute it only in staging, not live. So if this rule is trying to be activated in production and the environment is not in the list of environments, then it skips the activation of this rule. So it wouldn't be part of the system now. So yeah. And something really interesting that I just discovered recently, that maybe that way you can create, let's call this like an instance. This is an instance of the system, like system instance. This is an instance which a process or a pod or whatever, and you deploy multiple of them. So you deploy other instances, like here, instance, and you can deploy multiple of them. So if you found a way to make them all aware of each other, which is right now there are libraries that I noticed that can do that. So if each one of these exported a small interface and it's aware of the rest of these, it's like 5, okay, 5, nope, all right. So all of them are aware of each other. I hate that. So that means when one of these pods has a high pressure, it can, instead of executing the rule, it can, and for every event, it can pass the event to another instance. This instance execute it and return the response, which then written to this destination. And it's important to return that also because this destination could be HTTP request, and like sync request has to be served from the same instance. So you can't really just have the whole rule. So you have to be aware of that. But in that case, you can have distributed computing over the rules, and you can deploy as many as you can. And even if one is under pressure, it starts to load balance its traffic over the rest of them. So it offloads any like high pressure to uh, other instances that are low on pressure. This part I didn't develop yet, and I'm still not sure how to do that. But there are packages, and I think maybe we can have a gRPC server or yeah, gRPC maybe. Any way to serialize messages and pass it and get responses. There is 0MQ, there is gRPC, there is an HTTP server, but it needs to be really like low latency so that it would be easy to, like, it wouldn't be high cost to execute something in another instance. It would be low cost because we're trying to save time here, not pay more time. You have networking and you have serialization and deserialization. So we need to be careful with this. Yeah. So yeah, you get also this benefit where you can, if your system is under load, you can deploy more or like other instances. And even if, and this problem, I think we had it before, we have a Kafka topic that has only maybe 3 partitions and it's really high traffic. So your consumer want to do processing for every event. So to keep up with that Kafka topic, you can't deploy more than 3 consumers. Because if you deploy more than 3 consumers, the Kafka will just use 3 of them and the rest will be sitting idle. So if you have this model here, you can have 3 consumers and these consumers, they can also fan out when they are under load. They can fan out for the rest of the instances that are underloaded, like underutilized. And you get more performance out of the whole total system. So yeah, here you go. This is what I will be trying to do. And okay, let's pick a name for this system. Pick a name. Pick a name. So yeah, it's really hard to pick a name for a new project. I need help. If somebody is creative here and you have ideas, please, 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 please. Need some ideas. Mm, mm, mm. So it's a system that is, so you can actually also consider it something like Apache Spark. If you introduce this pattern, it will be very similar to Apache Spark, where you have a job you need to execute and it executes over a cluster. But here it's more of rules, conditions, destinations. So it has also a little restriction on what is it that you're trying to do. It's not like a free data, like a data pipeline. It's more restricted. All right. So how to do this? What would be a good name? For example, this project, Benthos. I hate this name. It's really hard to pronounce. Benthos. Benthos. Yeah. So, what kind of name should I give it? What kind of one? Sometimes they call these systems that output many event fire hose. Real-time data streaming API. Yeah, alright. Okay. Amazon data fire hose. Band. Alright. Is blue sky fire hose. So it's so we can call it fire hose. Alright. Let's go. So code fire hose main.go. Now let's write cmd fire hose main.go. Right. Okay, so I'm using Emacs here and Ghosty. I migrated from KT to Ghosty. I don't know, it felt, I don't know, more put together maybe. With KT it feels more raw. Like here I can make a new tab and it uses GTK tabs. It uses GTK tabs. While in Kitty it has its own rendered tabs, like in the window itself. Okay, so first let's go mod init firehose, initialize that, go mod tidy, sure, why not? And oh wow, okay, nothing to commit. All right, very good, very good. Okay, now we need to write. Let me show you first what kind of API I'm looking for. So here, what should happen is looks like that. Import GitHub mad Said firehose. Should look like that. And you have a main, and then you create a new firehose instance, and you can create a new firehose. Or wait, no, you shouldn't even need to do that. You shouldn't even need to do that. What you need to do, we'll try to reduce the types that are exported from our package to the minimum. So we wouldn't introduce types unless it's absolutely necessary. So context. So what you will do is to create a new context. Context background. Yeah. And then you can define a new role. So you can do this. You can define one, or let's have it here first. So let's say you are consuming from Kafka. So you're consuming Twitch messages, for example. So Twitch messages, and it would be a role, like a fire hose role, and you can say the source, and I want the language of the rule to look like you are saying what will happen. So what I want to say is like, you can do this. You can say, because Pentos has that too. Like if you look at Pentos, it has that when it's defining something, it says input, pipeline, output. But actually it could be better. You could say when fire hose, or like a sources dot Twitch chat message, that's a source, and just something like that. When, and then if, and you can say uh, message contains profanity is true. It contains profanity, then we don't need to do anything. Just so we need fire hose. Maybe we have actions. Like, let's say actions yield, which is actually doing nothing. Maybe we can also say nothing here. Or no. We can have our own action, and our action is which chat user. So this takes a message and return a user, and then the destination would be destination to db table, and we can say the table name is Twitch band, and would look like that. So this is a role that says, yeah, if this happened and this is true, then let's extract some data from this input and write it to a database table. And then you need to say fire hose, add a rule, for example, and then fire hose start this context. This is nice. Copilot is completing the line. So this is what I'm trying to achieve, and it would be nice also if you do this. You can take this way out of that, and you can define it outside, because you can define something like that here. So you can define it like that. Even better, you can do this. You can define like Twitch messages go, and it's a file, the same package, and you define the rule there, and you just activate it here. And because it's in the same directory, yeah, they are in the same package, and you can activate it. And if you want to remove this logic of banning someone, you can just delete the file and delete the activation, or you can keep the file and just don't activate it. Or also you can say environment production, or you can have like string, like an array of string. What was that? Yeah, so you can say, yeah, this works only on production or works only on staging. And the engine would look at that, and you're activating it on staging, it works. You're activating it on production, it doesn't. And then we can know the environment from environment variables or something. That's, yeah. So this is the idea, is that you have this kind of abstraction or DSL that you can activate, and then the system can know, okay, we have Twitch message, and I have 30 rules that need to react to this message. So it goes and passes this message to all 30 rules. And then the conditions would filter the rules, and then the actions would run, and the destinations would execute. So when an error happens, you can localize it. When a panic happens, you can localize it, and you can add more features. So you can ban a user once, maybe per month. So you can say when, if, once, every month. So you can say like this is time hour, so every 30 days. And you can can do this. You can do that. So every 30 days. And the engine, when it's activating the role, would look at this once, and this middleware here we'll see, oh, okay, the role has a once attribute on it. Then I would grab it. Otherwise, it would just not do any extra logic. And maybe it connect to Redis and keep track of the input and the TTL, and the TTL would determine it would be like 1 month. So when it expires, it disappears from Redis, and then the middleware would check again and doesn't find it, so it lets the rule gets executed. It's very extensible that way. Yeah, you can say instead of once, you can say cache. So caching means you don't have to execute the action. Sometimes when you're executing an action, it's really expensive. So you want to cache maybe for 1 hour. So you can say this is like time hour. You just execute this action once per hour for every input. So if you get the same input like a million times per hour, you just execute it once. That's it. Yeah. So you can have this DSL and this destination. Oh, this is also something that would be better. I can say 2. So when this happen, if this condition is true, let's have a cache for 1 hour. And if there is no cache, then you would get the user out of the message and write it to a database table. And in another rule, if you want to write to a database table, you can reuse this. If you want to get the Twitch messages for another rule, yeah, you can do that. So you can reuse the parts of your logic because you split them. Now you have sources of events, you can reuse them anywhere, and the actions you do in the system, which is the side effects or whatever the system impacted by. And you can reuse also this part. So if you make your components generic enough, you can reuse them across roles. And it would be very interesting to see the system evolve. And it's nice also when you build a system like that you can share sources and destinations and actions with other teams. If they are using the same engine, you can just share the source with them, or have or they can import the source out of your package. Because Go you can import right away. So it gives you really interesting properties. Yeah. So what about sequential execution of rules, especially when the output is one that is needed on the other to run? Yeah, we we found this problem actually. So this system is assuming that you can completely isolate your logic from each other, and they don't depend on each other. So you don't have an output from one that goes to the next. So it assumes that. And if you have this case, probably this is not the best architecture for you. But you can solve it also by having another, like reusing this idea in another way. So you can say, so let's say when you block someone, yeah, I'm struggling to find an example. So our problem is that we want the output of one role to be an input to the next. So that means your next rule, the input isn't actually the same source. The input is something that, oh, wait. Yeah. Like I'm designing for parallel. This is true, but we found this problem where we have this sequential. Oh, okay. Let me tell you what was the solution. So we have a problem where you get one event and you want to do something for every user. So you have like 1,000,000, 2,000,000 users, and you get one event and you want to process all 2,000,000 users. You can just process all of them at the same time. So what you do is that you have an intermediate step and you write to a queue or you write to a Redis set, and then you have another role that consume from the set and execute that. So let's say there are many things that can block a user. So what you do is that you can have a rule that says if it has profanity, then dist q or like SQS, and q is block user. So you write to a queue, you don't do the action, you just convert it to a message that will be processed later. And you can have another thing, you can have another role here where you can say if it contains nudity, then no, we don't. If it has nudity, we don't want to cache. We want to ban the user, even if they made the same offense more and more. So you can do that, extract the user and push it to block user, and this is message 2. And then you have a third rule that will consume from this SQS queue. So you can say when the source SQS, and this is the queue name. Then we don't want to do specific thing. We just need to write it to a blocked database. So you need to, what was it called? Yeah, to list db and write to the blocked users. So here you built two rules that will output an action to block a user. Write it somewhere, and then another rule here will pick it up. This somewhere needs to be in an external system like shared memory, because if you made multiple instances of this system, you need them to also communicate with each other. So one will output this action like block a user, and then the other one will consume it and do it. So you can do that. So yeah, now you have like two rules that each one of them has a different thing. So also here you can have the rule for profanity on production and the rule for nudity on staging, and they are not, they are decoupled from each other completely. And both of them, they will take the action of blocking the user but not record it right away, put it into a like intermediate system. And then you can have a rule that will consume from that intermediate system and do the thing. So when you block a user, you can write to a database table, and you can notify on Slack. But you can do this and Slack, and you can have the channel Twitch moderation. So you can have that. So you can have multiple rules that are emitting, hey, block this user, block this user, block this user. And then other rules that when a user is blocked, you can do also multiple things. So I hope this is clear. So yeah, with this pattern, you can think of it, you can make really elaborate designs with it. And if you have that, you can start also to have maybe a higher concept where you have like a chain of rules. And this chain, you don't have to specify what would be the queue between them or the communication medium between them. And the engine would orchestrate the communication. It would make the queue itself. It would make like a Redis queue or a Redis set and make the rules like the output of one goes to the other. And it would be interesting. But also we need to be careful because every concept you add to the system makes it harder for engineers to understand. If an engineer just join your team and try to understand what's going on, if you tell him, okay, you have a rule, you have a source, action, destination. That's it. That's all you have. Understand that and you're good. And then you have all of these rules. You know, all of them are following the same pattern. It's like the MC, the model view controller pattern, MVC. When you open a project that is MVC, you immediately get the grasp of it. You know, yeah, that's the logic. These are the models. This is the views. So yeah, I know where everything is. With that, you're also having the same thing, but instead of MVC, which feels like a little scoped just for something that has a UI or has like a model in the database, here you get a more generalized system, generalized architecture. So yeah, I hope that answers your question, Islam. So this is what we're trying to build, and what you do here is you try to activate the rules. Message 2, and the fire hose message 3, message 4. And if you're far enough in the future, you can have this as YAML instead of a structure. And you can have here something that reads from YAML, read rule, and rules.yaml, and you can just fire hose and activate or like add rule from YAML, and it will add the rules that you read from the YAML file, and you don't need to do that, or JSON, or from the database. So you can get the source of your roles from different places. Yeah. So yeah, this is the idea. That's what I'm trying to achieve. So now let's write some kind of a specification for that. Let's write how, what is the end product that we need to have. So not the implementation, but the general API. So if you are a developer and you want to import this package, what is it that you should expect from this package? And I think we can do that in one really long page that onboard the person on the idea, onboard them on the components, onboard them on how they work or like the features that they deliver, how to define the rules and how to activate them, and kind of move you through like onboard you, but it's like a novel where you are just going through the story. And the implementation would be just a small detail. And then people maybe can take an agent and implement it themselves. Yeah, that's a thing. So they can one-shot the whole rule engine. It's interesting times, to be honest. Very interesting times. Still some coffee. I'm having coffee at 6:50 p.m. So I'm not gonna sleep. Perfect. Okay, how about I take a break for like 5 minutes? I'm not used to talking for that long, so it's been like an hour and a half talking. So let me take a break for 5 minutes, and then we can get back and start to write this specifications. All right. All right, I'm back. Cool. Yeah, I have the chat open on my phone just to see it here. It's really bad that phones nowadays has to rock that hard. I have this Samsung S26 and just you put it on a disk, start to rock like a boat. Come on, like I know I never designed hardware, so I can't really say anything. Whatever I say is gonna be just from the customer point of view. Which should be, yeah, anyway. I'm a customer, I should have a say in, in this stuff, but whatever. All right. So if you just joined us, this is the idea. You have sources of events and the source emit event, and then the engine would pass this event, like fan it out for multiple logic that may react to this event. And when it reacts in a way that doesn't have a side effect. So the action just take an input, return the side effect as an output. And then the destination is the one that execute the side effect, as in writing to a database, writing to a file, sending a message somewhere. So you kind of isolate your system parts in a way that then you can mix and match. So you can have the database destination do something else somewhere else, like, so you can just put them together like a Lego. And it is fun also because you can wrap this kind of small units of logic with middlewares, and every middleware can add a feature, depends on the definition of the rule. And the end game is to have multiple instances in different machines interacting with each other to distribute the load on each other. Yeah, because not all the time you can actually get the load distributed already. So you can get like one process is hammered, so this should be able to, like, distribute the load on the rest of them. Remind you of AWS step functions. AWS step functions. What's that? Let's learn something new. What's this? Workflow orchestration. All right. So
Developers building distributed applications are continually overloaded with the
I
need
think
for
you can hear the audio. Sorry. Hmm. Yeah, so it's like a flow. All right. So it's like flow programming. And it has a UI. Yeah. Yeah, you can build a UI on Firehose. Now I will call it Firehose. But yeah, you can build a UI that build this kind of flow and then translate it to rules. And then you can execute that in the engine. You can like activate it, update it there. So if you get the core right, all of these could be built on this basic idea. Hmm. I guess it's the same, yeah. Very similar. Very similar. Yeah, automate ETLs, orchestrate large scale parallel loads, Microsoft. Yeah, today I learned something new. And how much is it? How much is this? Is this service? 4,000 state transitions per month. This is 25. So it's like 25, like 2 cents, 2.5 cents per thousand state transitions. And the state transition is each time a step of your workflow is executed. Oh, shit. You are charged for the total number of state transitions across one state. Oh my god. If I used this service from AWS in my production, probably the whole company would be broke by now. Look at simple YAML workflow, you will get good inspiration from the rules. Yeah, yeah, exactly, yeah. But man, it counts every role towards your pricing. Damn. No wonder they are making a shit ton of money for this stuff. Nope, nope. That's, I don't know. Like sometimes I feel okay. We are developers. Why don't you just build the things you want and you would be totally in control of it and you can extend it as you want. With that, you can control every aspect of it. You know. Yeah. No, nope. Thank you. Pricing is crazy. Yeah. Yeah. Pricing is crazy. Okay. So we need now to write this idea in a more respectable way, like a clean way. So when somebody joins us tomorrow, after tomorrow, you know, after a week, they kind of get onboarded when they look at this document. So, all right, let's write readme.md, and this is firewalls. Okay, how do we define that? The Lego, yeah. Okay, so how do we define that? So we need like the elevator pitch. But what is that? This is a system for processing events. Too dry. Okay, what do we aim to do? It's like high performance rules execution engine in Go. Is it built on top of a known pattern? This is known as business rules engine, I think. Business rules engine. BRE, yeah. A system that executes one or more business rules in runtime production environment. The rules might come from legal regulation, whatever. Typically support rules, effects, priority, mutual exclusion, preconditions, and other functions. So it's that. Yeah. Inference engines, business rules approach, design strategies, yeah, BPM, process management. So it is like that, and there are some engines that are pretty famous, but they are really ancient. There are engines where you write in text, like when X happens, do Y if blah 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 in text, and it kind of parse and understands what's going on. Yeah, see, all customers that spend more than $100 at one time will receive a 10% discount. So this is a rule, you know. So you add it there, and then the engine will know, oh, okay, all customers that spend more. So the event is when the customer pay, and then you will check in the condition: is it more than $100? Then add a discount. A discount is like add something to their cart, like a discount to their cart, or change something in the request. Or yeah. Better use the pattern name and add your selling a point afterwards. Yeah, business rules engine. Yeah, right. High performance business rules engine in Go. Supporting caching, running once, throttling. What else? There's also debouncing. Debouncing is like when you get like 100 events, like one user that just sent 100 comment. So you can say, oh yeah, no, just debounce it and react to the last one. It's similar to places where you are here and you are just typing, it debounces and then react to what you're writing. Debouncing, throttling, caching, yeah. Tracing, logging, tracing, monitoring, and many more. I also want to set like what kind of restrictions we are trying to have. So we're trying to make it with zero allocation. That's gonna be hard. Allocation, zero allocation. What was the other thing? Zero allocation. So I don't want allocations anywhere as much as I can. So no heap escapes. If there's something that escapes the heap, it needs to come from outside. Yeah. So you don't allocate yourself, you get something from outside. As much as we can, I think at some point I will not be able to deliver that, but let's be hopeful. So zero allocation. Yeah. Allocation. All right. Okay. Okay, so this is what it is in general. Now we need to maybe describe the problem that we're trying to solve. So many systems are modeled around the idea of reacting to events such as HTTP requests, gRPC methods, requests, a queue message, Kafka message, RabbitMQ message. Such as and these systems process these events in a whole different ways. These events in different ways. These systems, these process these events in different ways. They decide which logic, or like they have preconditions and side effects that needs to be applied to the system. This pattern, when not enforced, leads to many tight coupling. Is that correct? Tight couple. Yeah. Okay. Leads to many tight coupling and the system becomes hard to maintain and very brittle when changing. So yeah, you change something here and it breaks something there. So this is the problem. So many systems are modeled around the idea of reacting to events such as this and this and this. They have preconditions and side effects that needs to be applied to the system. This pattern, when not enforced, leads to many tight coupling and system becomes hard to maintain and very brittle when changing. Also, maybe it's a sub-problem. Instrumenting applications are manual in most of the cases because the number of different concepts in the system doesn't allow for a generalization. Yeah, because you have like many classes and factories and builders and blah blah blah. So you have to go everywhere to add tracing and logging and monitoring it. It's kind of a mess. So when you enforce a specific pattern, then everything falls under these concepts. So then you can wrap the concept. So if you have like 3 4 concepts, now for every concept you can start to wrap it with more stuff. While if your concept is just that you're executing a function or you have like so many different concepts in the application, that becomes hard. So it's kind of to manage the complexity of the system. So instrumenting applications are manual in most of the cases because the number of different concepts in the system doesn't allow for a generalization. Leaving I guess this should be the problem. Also, the cost of introducing parallelism. Why does it look so retarded? It's with S. Oh, no. Yep. Sorry, I don't speak English or Arabic. I don't speak at all. Also, the cost of introducing parallelism and distributing computation becomes a headache. So the solution, the general idea of the solution is that we need to do several things. We need to enforce, no, first break. What I need to say is that we need to end up with a very specific and a small number of primitives. Limit the number of system primitives. Primitives also. Okay, where is it? Yep, that's it. There is something also that I did uh, today that probably I shouldn't do that, but anyway, I was using a Space Max and now I'm using Doom Emacs, so I just switched today. So many of the muscle memory that I had, now it's gone. They have similar things, but not always. So yeah, one of them was the correction, the spelling correction. Limit the number of system primitives to control the complexity. So limit the number, the system primitives, and define a clear pattern for all events processing, sync and async. Allow developers to define logic in isolation instead of iterating over the same piece of code. Also, in the end, come up with a DSL that makes it easy to communicate the system behavior between dev and product managers. Also, when you do all of that, we need to allow for component usability in the system and between teams that uses the same system, same course and library, same package. Reusability, okay. Oh, it's not one word, right? Devs, developers, right. So this is the general idea, or let's say it's the goals. Like when we do that, whatever the solution, it will solve the problem. So if you limit the primitives, you make it easier. You make it easier to make like decoupling between the components and make it easy to understand. Define a clear pattern for all events processing, sync and async. Allow developers, yeah, and defining in isolation. This is also solves the coupling part. And the DSL allow for instrumentation and generalizing over the DSL. Allow for component reusability, and the reusability makes it easy also, like, wait, which part of the problem does this solve? Yeah, it's the repetitions, like the beginning. And many systems are modeled around the idea of reacting to events, blah blah blah. It has preconditions, yeah. So when you have reusability for your component, you can save some time. Makes it easy. Actually, the agents are way way more easy to, like, it's way easier to work with agents in a project that has this many, like, this less complexity, less many primitives, than working in a project that has so many different patterns and inheritance and solid principles everywhere. Solid principles. I remember time where the solid principles was the thing that everybody was like, it was all the rage, and like all the comments was like, oh, do you know solid principles? Okay, tell me what are the solid principles. And if you don't know it, you are considered not a good developers. Now everybody's like, no man, that's too old. That's like, that's not how we work now. I don't know if this is good or bad, to be honest. It feels like we were doing more scientific work before. We were approaching software engineering in a more of a constrained and scientific way, trying to fit it in patterns and try to like take properties and try to extract these patterns. And right now it feels a little quick and loose, kind of. Yeah, yeah, like the hype of clean code book. Yeah, exactly. So clean code and clean architecture, and you have the onion, and you have the hexagon, and you have all of this stuff interacting with each other. Now it's no man, we you just no keep it simple, just write it directly. And actually, most of the companies that I worked for is like, nope, let's just write what you need to do exactly as you want to do it directly with the least amount of abstractions you can, which which is really nice, which is. But also in the interviews, I used to be asked about that, and I used to be tested for being fast in coding. It's like, yeah, can you write an HTTP server in Ruby? Show me. It's like, yeah, here, file, couple seconds, and now it's running. What do you want to do with it? Do X and Y. Ah, here it is. Yeah, I had one of these interviews, and they were testing for speed. They were testing that, they know that you can just do the job, do the thing. When I tell you, hey, like I need this feature, you implement it. So yeah, they are testing you to be an agent. They're testing you to make sure you can pass as an agent back then, before the agents was a thing. And it's really impressive how the agents came to be in the past couple months. And it's been just 6 months. I've been using the AI agents, the Cloud Code, since September, maybe last year. It's came really long way. I was just using Copilot to complete the line function, but now just give it a link to Jira and wait for it to open the PR and make it green. And while it's doing that, I can start some other stuff. Does it matter really after you land the job? I mean, do we really need to be fast in writing code? They wanted to know that, because this is the thing. If you are in an interview and you can't write a hello world HTTP server, in like couple minutes, there is a problem. So you have to pass that at least. They have to know that you can write code and you can use the language and you can just come up with something like scrappy and fast. So that's a low bar to pass. After you join, of course, because let's say you didn't pass that. That means after you land the job, you would be way slower, because at least in the interview you already have the adrenaline and you're afraid and like tense and stuff. So you should be actually doing the same task faster in the interview than in your job. So if your speed is like really low in the interview, probably while doing the job it would be way lower. So yeah, I think it matters to test that an engineer can actually write the code and write it fast. Now, with all the agents and the AI and prompting your way to it, I don't think it's that impressive anymore. I think the impressive part would be doing things on a larger scale, which is not that fun. Do you think the approach will stay the same after the AI? this is the thing, like speculating the future with this fast-paced technology is really hard. So as you see, in 6 months, we moved from writing a function, writing a task, writing a class, refactoring some things, into running multiple agents that do multiple tasks at the same time in different workflows, and the agents in GitHub, and the agents reviewing agents, and the agents in the chat, and the agent like agents everywhere, and agents like for the incident response, and agents for like writing postmortems. So it's moving really fast that I think it's hard to speculate about what will be happening in the future. So all we can do is speculate. We can't predict because some people say, "Oh yeah, I know what's going on. Here's what's going to happen, X and Y and Z." And I've seen a lot of talks like that. It's like there is this conference called the AI Engineer Europe, I think, which has so many talks. I don't know when did they do that, but anyway, it shows up on my YouTube all the time. And so many of the people say, "Oh yeah, I know what's going on. Here is what you need to do because this is what's going to happen." And I don't think this is true. I think everybody's scrambling to understand how this will evolve socially and technically. Yeah. In your opinion, as a junior, what should I focus on these days to compete in the market? This is the thing, like whatever I tell you today, it can change tomorrow. You will wake up tomorrow and the cloud code can do something different that will change all the patterns that we have. So it's really hard to say right now, to be honest. Everybody is just sitting and waiting. Um, so waiting for it maybe to slow down a little bit, to understand what's going on, to digest what's going on, and also for the system to kind of react and settle down. Because as long as you have this fast-paced development, the system is not settling yet. So whatever you do, you can wake up next day and it's obsolete. So what you can do right now is what you were doing all the time and keep up with new stuff and learn how to use it. And whenever something comes up, just be flexible, adapt to it, you know. The more you adapt, the more you become, part of the people that will be making the future, I guess. The worst you can do is to be rigid, to uh, to reject all of that. That's the worst you can do. You know that the humans in general evolved to adapt to the environment, and all of this adaptation is what made us physically, can live in so many climates and eat so many food. And like my dog, if I change his food, he would have diarrhea all the day. So yeah, we are actually very adaptable. So I think we just need to keep at that. Learn the new tools, the new features, try new stuff, see if it's useful for you. Yeah. Do you think this approach will stay the same after the AI, in your opinion? Yeah. So we can be hyperbolic a little bit. So we can think what could happen. So the AI so far now can take a task and can do it. And some people managed to automate the way we approach tasks. So on a higher level. So now you can give an agent a product requirement document. How can I prevent failing into a rabbit hole when I'm learning about something? How can I determine if I have enough and should do something else? Yeah, what you can do is you have to build the judgment yourself. Nobody can decide for you. So you have to build the judgment. Your judgment should depend on what you are trying to specialize in. They are always talking now about the T-shaped engineer, where you are trying to learn a lot of things about like a specialty as a back-end engineer, for example, but then also know more about some technology. It doesn't have to be that deep. So you need to assess what you are trying to learn now. Is it part of your specialty? Do you have to go down in it? Or do you have to go wide? It's like outside of your scope. So you have to think hard a little bit about what you know. And this is even before the AI. You have to do that. So for me, for example, yeah, I'm learning Hadoop or I'm learning Kubernetes. Yeah, I can learn and get deep into it, but as a backend engineer, I don't need to learn everything in it and control plane and like and try to write controllers and stuff. That's not part of what I do. But I can know how Kubernetes works. And this is for most of the things. You need to build some kind of a judgment and also look around. So you need to look around at what people are doing. Because in the end, believe it or not, what we are doing is more of a competition. So we are competing on the demand of our skills. So you need to like check yourself and check people around you. Is people know more about this topic while they have your specialty? Okay, now we have a problem. You need to know about that. Is it a topic that not a lot of people know about it in your specialty? Okay, let's know about it. Don't go too deep and just move on. How do you know when to stop? This is something you have to decide for yourself. It depends also on what kind of topics you are trying to learn and how much time do you have. So it's not really easy. It's not really easy to decide when to stop and not. Yeah. So the AI, it's interesting. It's really exciting technology. It's really exciting. This is what I wanted computers to do since I was a child. This is what was imagined in the future. Computer, where is Captain Picard? He's on deck 9. By the way, I have been following you for a long time since you have been doing podcasts and talks about your side projects with Ahmed Assam and Muhammad Sharif, and I was following you on YouTube. Very grateful to have done so. Thanks. Thank you very much. Um, Bo Hamza, 69. Nice name. But yeah, thank you very much. I'm really flattered. It's really hard to put energy in this kind of projects because most of the time you are really burned from work. If you care about your work, you kind of go to work and try to do the most you can. And after that, of course, you wouldn't have any energy to do anything else. So it's a struggle a little bit to show up and do something that people see. Because also I can write this project without talking, without showing anything like the process as I do right now, which will makes it a little bit takes less energy. But also when you do this kind of streaming and showing people how to do that, the artifact wouldn't be just the code and the project. And we agreed now that agents can one-shot projects. So you end up now with just learning how the code works and how to read it and how to build it. So you need the experience. That would be the problem with the AI. That when you ask the AI to build something and you didn't build that before yourself, it will be hard for you to learn. The code is so much, and to go through all of it and check the primitives and how they are built and how they interact with each other, it will be hard. So you wouldn't be actually learning this specific kind of skill. So seeing somebody writing code and reasoning about the system can maybe build this judgment for you and will give you this experience. Yeah, I hope that's what it does. And I hope that's also what it does for me because the skill atrophy from using the AI is real. Now, when I was writing something in Go as a slice of strings, I just wrote the syntax wrong. Yeah. So it's not that easy. Yeah. Yeah, I have this project called, I think you are talking about Xlog. Yeah, it's still there and I'm using it all the time. My website is built using that. It's built here. And also if, by the way, my website has my stream on it. So at any time, if you want to check if I'm online or not, like you don't have to open Twitch, you can open the website and you can check. But yeah, the Xlog, I think that's what you mean. It's pretty interesting project because it's like infinitely scalable. And you can learn a lot from doing it because it needs a lot of optimizations. I think I threw it before on like 10,000 files of notes and it took more than 30 seconds to render them. And mainly because it tries to check in all the text if the other notes was mentioned in this text and link them together like in two-way linking. So it makes it like n power n, I guess. Yeah, n power n problem. So you really need to optimize the hell out of it. Yeah. So it's not that easy. May I ask what is your approach using AI? Which models to use and when to use them? Yeah, okay. So my two so first I try not to use the UI. I try not to use cursor or VS Code with like a sidebar or anything. These are all slow. Whenever your conversation goes like pretty long and you start to switch between conversation, it's really slow. It will waste your time. You don't feel it, but it adds up. And when you switch and it's slow, you kind of also get slower. So no UI, only TUI ones. I'm breaking that here because open code doesn't have like, yeah, anyway. So it doesn't have like diffs in the terminal. But anyway, so at work, open the terminal, and I have a small thing that can make me jump to any project. So I can jump to any Git project, bounce game. There you are. And then I can say space and C for Claude, and then W for new work tree. So what it does is that it creates a new work tree. Oh, so it starts Claude with dangerously skip permissions, so it doesn't ask for permissions when it's modifying files, and it makes that in a new work tree. If I want to have it in the same directory, in the same work tree, I use in new session. So I can launch a new agent here, Cloud Code, and then I open a new tab. I'm in the same project. I open another one and give it another task, like refactor this. Another one, a new work tree, and the workflow is outdated, updated. And another one, another work tree, there are security issues, solve it, and so on. So I open as many tabs as I want with the things that I should have done it manually and make them all do it. And I have my Cloud Code file tell it to run the tests, to run the linter, and then open a pull request and ask Copilot on GitHub for a review, wait for it to finish the review and address the comments and iterate until both of them are done, and then look at the workflows and make sure all the workflows are green. And when you're done with all of that, tell me you're done and stop. So I do that and I wait for them all to be done. Sometimes they ask questions or they stop in the middle and say, get lazy and stuff. And when they are done with their PR, I go and review it. Okay, so now the AI reviewed it together, so it should be better. But yeah, I have to review it and look at it. The approach sometimes is wrong and that, okay, like there is a structure that you defined, you don't need to define the structure. or a function you redefined it, you can use this function from utility package. Sometimes it can't find function somewhere. So I have to tell it what to do. Sometimes like tests that are bogus doesn't do anything, or tests that doesn't test anything, or tests that are just duplicate. There are tests that are testing everything, like redundant. Um, yeah, and I have in the workflows a lot of custom linters. So before the AI, when we used to just develop things, we used to have this comments in the PRs where people are commenting on really tiny stuff. Like, hey, this variable name should be X, not Y. Like, this file shouldn't be here or shouldn't be in this name format. Or this file has two rules in it. No, it should be one rule. Or this action, you remove these rules, the action is not used anymore, so it's dead code, you should remove. So all of this kind of stuff, the first time I see them and I know they can be automated, I ask the agent to create a linter, which is a test, to check for this issue. So that means when you run the tests and you fall into the same issue that we commented about before, it will fail and the agent will try to fix it. And because it's not a linter that can exclude it, the agent has to fix it. It can't add it to, like sometimes it tries to say, oh, no lint, the comment in the end I say no lint, so to make it excluded, or modify the file of the linter to exclude the file. It gets really sneaky. So when you write it as a test, it can't do that unless it modifies the test. So after I review the PR and it looks good, I push it to my colleagues to review it, and then we merge. And after you merge, you also keep an eye on the metrics and the dashboard in case something goes wrong. Sometimes patterns start to emerge, like the IO start to have like spikes, or instead of being like stable, start to be really low and really high. So there's something off. So you have to keep an eye on the metrics. Not everything can be checked with an alert. Yeah. So this is what I do with AI. Also, I connected the AI to the cloud. I connected it with Atlassian because we use Jira and GitHub, so it can open PRs. So now when I see a Jira ticket that seems like I can just throw it at an AI, I take the link, open a new work tree, and paste the link and tell it to do the ticket, and it does it. It gets the text from Jira, do it, and iterate and do all the things that I said, and then open up a request and tell me when it's ready. The part that I need to automate next is to have a system that looks in Jira for things that are easy to throw at the agent and picks it up and work on it. Not yet. And we have automation also in GitHub, so I can mention Claude and it will do stuff in the PR. So I can tell it, hey, like change this and this and that, and it will do it. So we have, it's not Claude code review, it's Claude code. It's the Claude action. Yeah, Claude code action. As for the models that I use, I'm using Claude Sonnet, the latest version, and Opus. But most of the time I'm using Sonnet because Opus is really expensive and sometimes it's taking longer than it really should. It overthinks stuff. So Sonnet is pretty good. So I use Sonnet, which is the last version. I don't remember even the version. 4.6 is it? 4.6, yeah, yes. So yeah, so you do that. You have to also pick a terminal that doesn't choke on the text. There are some terminals like the GNOME terminal, I believe, or KDE. They choke on text a little bit. So the longer the text, the harder it scrolls and they get sluggish and stuff. So you need something that can really handle text well. Yeah, so that's what I do. Also, I connect it to Slack because when there is an incident, it's reported on Slack, And when you're writing a postmortem, you can tell the agent, hey, like inspect this channel and search for stuff and write the postmortem and add references and make sure everything is referenced and everything is correct. And also for research, sometimes I remember, okay, we talked about this topic and we agreed on that, but I don't really remember where is it. So I can just fire an agent and ask it, hey, check my conversations and chats in several rooms and try to find where we agreed on this kind of business decision. Sometimes these business decisions are taken like in Slack threads because it's like small or modifying a really small behavior or something. Yeah, so how do I decide Sonnet or Opus? My default is Sonnet. So by default is Sonnet. And then Opus when I see something that needs a little bit of architecture. So sometimes I have problems that I know it needs a little bit of experience. I know that you need to rethink maybe the approach of the project or see something architecturally wrong. And in this case, I try to use Opus. But also Opus overthink, so and it's really slow and expensive, so I try to be careful when using it, especially that it seems like I'm overusing AI at work compared to other people. So I need to be careful a bit with my usage. Yeah. Also, I have some skills that I built that can pprof services and like analyze the pprof for CPU and memory and heap and suggest improvements and just tell me, okay, like which ones do you want to implement? And it implements it, makes benchmark, and open a pull request. I have some skills that can follow pods on production and check for errors and check if the error has something like inspect the error and try to investigate and find the issue and makes a report or fix a bug. So yeah, I have some of these. Do you use AI code completion with Emacs? Yeah, yeah. So I have Copilot. So if and it's what was it? Packages? Yeah. So I'm using Copilot. Um, and it will start. Where was it in the config? Copilot. Yeah. Here. So yeah, this is like the config map, like tab and control tab and stuff. So yeah, I just log in with GitHub and it uses it. Yeah. What do you think about DeepSeek, Minimax, and the other Chinese models? Do you use them or just Claude? No, just Claude. I think I tried to run DeepSeek R1, the small model, on my machine, but it was slow. Let's see. So it was DeepSeek R1 Olam. It was on Olam. It was slow and I couldn't use it for anything, to be honest. I think it was when R1 came to be. I think I ran the 7. I think that's wasn't there 4, or was I hallucinating? Yeah, but no, local models doesn't work. Even if you have a beefy machine, let's say you get one of these framework PC. It's really beefy and it will cost you maybe 4k euros. But you run one model and you're limited by the size and it will be slow. You are not going to get the same speed as when you're connecting to Claude or to Anthropic. So imagine if you are opening multiple tabs and it's local inference. That wouldn't work. What you may use it for is small things. let's say you want to summarize text, like in my blog, for example, and I want to generate the metadata that is in the header. Maybe I can use a local inference model. Yeah, you can give it the text, tell it to summarize it. That should work, but you wouldn't use it to as alternative for Claude or for Opus, for Sonnet or Opus. But I also noticed that their prices are really cheap nowadays, and they are competing on prices. So I guess if you are low on money a little bit, you can maybe use a Chinese model. I haven't used their platform, so I can't tell you how good is it compared to Sonnet. For example, like the Claude Open Code here, they have this model, and I used it, and it seems like it's a little lazy. It stops there and says, "Ah, no, I couldn't do that. Can you run this command?" Come on, man! Like I'm asking you to do it, so why are you telling me to do it? It's like getting a plumber, and then he sits down and sips tea and tells you to fix the leak. It doesn't work. So yeah, I don't think I can be of any use when it comes to performance comparison. And the websites that compare performance are really also doesn't tell you the whole truth. So you have to really try the model in your context. Otherwise it wouldn't really give you complete view of what's going on. Yeah, this live is recorded because this is Twitch, and Twitch will records everything. Yeah. So you can get to Twitch and you go to past streams and you can watch it. I think I need also to post that to YouTube. Anyway, let's get back to that. And these are maybe the goals of the solutions. This is the problem. This is what we are trying to solve with the solution. If our solution achieved this kind of things, then we're good. Let me drink some. Okay, so let's say these are the goals. Now let's talk about how the concept looks like. So here, let's just be a little comfortable with this glue. When you get older, it's really hard to just maintain your posture without getting injury. Anyway, okay, we can imagine. So how do we write that? I want to say that we could imagine our systems, as follows. Source, a source of events, like an HTTP server, Kafka consumer, Redis set or Redis set consumer, file system watcher, precondition condition that determine if the logic ahead should be executed for this event. And condition and then action, and the action a component with the input event takes the event as input and produce an output that represent the side effect on the system. And destination, destination, a component that will apply the side effect to um, to the system or external system. So condition like let's say valid true, for example, or has profanity true, or blocked false, or could be any combination of that, so it's a condition that you need to check. An action is like extracting data from input, convert which message to block event, or reduce the size of a large input to just the needed attributes. Yeah, the action could be something like that. And the destination is writing to database or Kafka or Redis or HTTP response. Yeah, so anything that you're getting an output from the action, you want to put it somewhere. Yep. If it's correct, why does it have this line? Come on. There should be a dash. Yeah. All right. So these are the high level concepts. An example. Oh, wait. A combination of these four components will be called rule, as in business rule. All right. All right. So an example. An HTTP request. HTTP request to get list of a list of customer payment methods. The condition validate the customer is logged in. The condition So yeah, this is the payment method. This is source precondition, and if so, get the list of payment methods for this customer and return a list. This is the action. This is what takes the input and convert it to an output. And write the list as a response, as a JSON response. This is the destination. Or consume Kafka topic users, user information, validate the message is valid the message. If the message is valid, write it to database table users. So for user information, this is the source, which is the Kafka consumer. The message is valid. This is the precondition, and write it to database table. This is the destination, and you can go on. Yeah, 2 examples is enough, I guess. So yeah, so combination of these 4 components will be called a rule as in a business rule. Yeah, high level concepts. All right. Okay. This is the high level concept. So organizing our system in such pattern will allow for wrapping the rule concept in different wrappers that adds functionality. The rule definition itself, definition, the rule definition decides if decides if the feature is on or off. Example, so logging. This logs the rule execution status, success, error, skip. Metrics can report Prometheus metrics, for example. Tracing report hotel tracing for each part rule and part of the rule. You can have caching. Decides when to cache and if to read from the cache. Panic recovery. Limit the impact of panics to specific business rule. So when something fails, you're not filling the whole request, you're filling just a small part of the logic. Yeah. Execute once, checks if the input was, make sure the rule is executed once per input. All right. Open telemetry. Open telemetry. It's written OTEL, right? OTEL, whatever. All right. So this is the high level concept. So this is the execution engine. So an engine should allow for defining the rules in DSL format, add, remove, update rules in runtime, and fan out events events to rules expect using same source, and allow for wrapping the rules with extra logic and features. So yeah, we had something here related to the responsibility. So the wiring, yeah, managing the rules, safety net, yeah. Responsible for safely executing each rule without degrading the whole system. If one rule is faulty, yeah, so you have like 300 rules and then you rolled one and it panics. Yeah, the rest shouldn't be bothered by this. Do you usually build your markdown files, skills and rules or readme like this one from scratch? I mean, why don't you use the model to do some kind of interview with you to do this? I'm using this method. Yeah, that's a good idea. I would like to hear from you if there is an advantage in building it from scratch. Well, yeah, so when I'm building the skill, I usually tell the agent to do it. So I'm already like in a session and I did something like I made pre-proofing and I did several steps. So what I do is that I tell the agent, hey, what we did here, extract it as a skill and write it in your configuration, in the Cloud Code configuration. And yeah, usually it does that. I go and read it and try to minimize it a bit because it's usually really chatty. But here in this project, I'm trying as much as I can not to use the AI. And this part is also a little critical. I don't want any slop on it. Sometimes the AI try to come up with concepts or come up with like fancy words. I don't want that. I want that to be intentional as much as I can. The AI kind of removes the intentionality from it because it takes your words and expand them. So it has to fill in things in the middle. And this is the part that is not really that much intention. You didn't really say it that way, and the AI is filling the gaps for you. So yeah, and in our case here in this project, I will try to minimize the use of AI as much as I can. I will try to use it maybe in a throwaway code when we have benchmarks or something, different concepts we want to try, but not for this project. Also, as I told you, it's the skill atrophy. I would I would like to combat that with writing manually and thinking through everything, and it's fun. It's fun. All right. So this is what the execution engine does. Can also um, communication with other instances to distribute workload. Mhm. Yeah. So yeah, it's executing the rule locally, but also it can communicate with the rest to execute remotely. That would be great. Yeah. Okay. So non-functional requirements, non-functional goals. Okay, so we need zero heap allocation as much as we can. That will be brutal. Um, I remember I had some. Oh, okay. Maximum Golang CI linter configuration. Because usually I don't enable all of them. I will try to enable as much as I can. And there I can use the AI. I can write my code, make sure it's working, and then the linter is failing. Okay, the AI can help me with that. So these are things maybe I can use the AI for. Yeah. Or to review the code. Hey, like, is there something here I'm missing? Is there like edge cases I didn't cover? The AI would be good with that. So we have this. Ah, minimum, minimum, minimum dependencies. Yeah, I really hate to add dependencies to my project. So as much as I can, please, let's not add dependencies. Let's write our own stuff and be in control of the whole thing. Mhm. Minimum exported interface. Yeah, I don't want it to export like 1,000 structures and functions and stuff. No, really small things. If we don't want, if we can get rid of a type, yeah, let's do that. If we can get rid of a function, let's do this. If we can unexport a function, make it internal, let's do that. So yeah, that would be great. That would be great. Yeah. Yeah. Okay. This is the non-functional goals. Here we go. Okay. Now GitHub. Let's create a new repository. Not issue. Come on. New repo. The owner and fire hose. High performance. Oh, right. Okay. It's public. Blah 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 blah. License. I really, really, really want to make it a GNU license, so businesses doesn't just So who will use that? People that want to do open source projects for fun. I really want to avoid companies taking this project and just running with it. It's not gonna be that like let's not take it that seriously. It's a pet project, but still, if this will happen, I don't want this to happen. But what's the difference? The GNU Hero general license and GNU general license 2, 3, GPL. Let's check this. It was. There was something that checks it. Wait, there was something also like Go Docs doesn't Go the website for Go Docs. I think it doesn't index your package if it doesn't have license, but does it index it if it has GPL? I think it had this problem. I didn't add a license, so it didn't generate documentation. So I really need it. All right. So license, create, and here we go. So this one and add origin and the URL. Yep, full. It added a license, right? Oh, I see. Okay. All right. Be right back. Okay, back. Yeah, I was unlocking my password vault. Hmm? Lies. Um, sorry to be the only one talking, but I'm still junior and I don't have enough knowledge to discuss with you about this project, even though I'm trying to learn as I can. So my only way to interact here is asking about using AI to maximize my project. Yeah, I know. And everybody's trying to do that now. It's not only you. Yeah. So lies. What the hell? Okay. Maybe there is no master on my local machine. So anyway, so the readme and the go mode, and that's it. Initial design, and yep, there you go. Let's rebase. What? Rebase is different here. No, it's R. Oh, okay. Not pressing R. Actually, go. P. Okay. Now we have this push, and we should see it here. Alrighty. Okay. Okay, I think I will call it a day. We have been here for maybe around 3 hours. So let's maybe continue tomorrow. Let's continue tomorrow. Tomorrow we can continue to write what is it that we're trying to do, not the implementation, what is it? A rough interface to get an impression of what is it that we are trying to achieve in the end. Like when you get this project and you want like you want to build an engine and you need to have events and register it. Okay, like now what? So yeah, let's see. All right, thank you. Thank you, thank you, Bo Hamza, for all the questions and for following. But yeah, I hope that was useful for you. Okay, tomorrow will be It will be a business day. Today is a holiday. This is why I was able to do this long stream. But tomorrow is a business day, so maybe it will be late in the evening. Maybe it will be like 8, 9. Let's see. Let's see. I will announce on my Twitter account, and I will try to always, like engage as much as I can on social media. Um, yeah, I'm trying to, like, push a little bit my presence in social media, especially Twitch. It's interesting. I want to know how far I can go on Twitch. I know there is not a lot of money in it, so probably it wouldn't be money. It would be more of, engagement, knowing people, getting more ideas, also practicing coding again. Yeah, something like Islam when he was telling me about this like a step function from AWS. Yeah, I didn't know that. So yeah, I hope that would be like me learning stuff and you learning stuff and exchange ideas. It would be great. That would be great. And I need to learn to relax more when I'm streaming because I'm too fast. I usually don't talk that fast in real life. Anyway, thank you very much and see you maybe tomorrow.